turns out that if we look at rectangular prisms, we can actually consider the diagonal inside that rectangular prism. Let's take a look at an example. What we want to do here is actually find the length of a diagonal of a 5-inch by 7-inch by 10-inch rectangular prism. Let's draw a picture first and see what is going on. So let's just draw a rectangular prism. Okay, and I'm going to put in the invisible walls. You might not even be able to see this from where you're sitting, but I'm putting them in. Hope you can see them a little bit, maybe. Now, what is a diagonal? It means that we go from one vertex to the sort of diametrically opposite vertex. So it looks like this. Cuts right through the inside of that. Right like that. Now, how would you find the length of that? Well, actually, if you look closely, that actually is the hypotenuse of a particular right triangle. Draw this right triangle, and then put the diagonal along the floor rectangle, and this becomes the hypotenuse. Well, this we know, that's the height, which in this case, I guess, is given by 5. And, well, we know that this length is, let's say, 7, and this length is 10. So I can use the Pythagorean theorem to find that hypotenuse along the floor, and then use that as the leg of this bigger right triangle, and actually I can produce, in fact, this length right here. And if you think about it, the formula would this be, we take this length squared plus that length squared plus this length squared, and take the square root, and that produces exactly what we want. So the diagonal of a right rectangular prism is just the square root of the sum of the squares of the various lengths. So in this case, what would it be? Well, in this case, what we'd see is the square root of 5 squared, which is 25, plus 7 squared, which is 49, plus 10 squared, which is 100. And so what we'd see here is the square root of 174, and the units are inches. So there you have it. Pretty easy stuff. Once you realize that it's actually just a hypotenuse. All right, let's try another example together. Let's find the height of a rectangular prism where we have 3 feet by 5 foot base and a 12-foot diagonal. So this is a little tricky because here we know the diagonal and we want to find the height. So how would we do that? Well, we've got this formula here which tells us that the diagonal of 12 is going to equal the square root of the length, which is 3 squared, which is 9, plus width, which is 5 squared is 25, plus the height, which is what? Well, we don't know what the height is, so I'm going to call that h squared. I can solve this by squaring both sides, so I see 144 equals, and then the square root now lifts, and what I see here is 9 plus 25, which is 34, plus h squared. If I subtract 34 from both sides, so I have h squared alone, I'd see 110 equals h squared. If I solve this for h, technically I have to take plus or minus the square root. But in this case, h is representing a height, which is a length, and that means that that's got to be positive. So in fact, I know that I'm only looking for the positive square root. Square root of 110 equals h, and so the answer is the height is square root 110 feet. So we were able to find the height just knowing 2 of the dimensions of the rectangular prism and the diagonal using this formula. Pretty cool.